Good afternoon. Let's now start with our third lesson, which is talking about mechanical energy. But before talking about the mechanical energy, let's talk about the types of the energy. Now, the energy, it could be mechanical or not mechanical. Now, by the way, we have many types of the energy: mechanical, chemical, thermal. We have chemical energy. We have thermal energy. We have electromagnetic energy. We have nuclear energy. So we have many types of energy. In this lesson here, I classified for you. So one for them is mechanical, and the others are not mechanical. The not mechanical energy, such as chemical, thermal, electromagnetic, nuclear energy, and so on. We have many examples, and gravitational energy also. We have many examples for the not mechanical energy. In our lesson here, we are going to talk about the mechanical energy. The mechanical energy, they are kinetic and potential. They are classified into kinetic and potential. And the potential is to be classified into gravitational and elastic. So let's talk about now the potential in a few words now here. And what is the kinetic and what is the potential? A potential, it is an energy that is stored. When I am at rest, when the ball is at rest, everything, when is it at rest, it has an energy. It is stored an energy. This energy, we call it potential energy. And once I'm moving, my kinetic energy now will start counting on. So a kinetic, it is energy from the moving when object is in motion, and the potential with an object is at rest. It is stored, it is the energy that is stored. Now later on in the next lessons, we will talk about them in detail.
Teacher?
Yes.
Teacher, in chemistry we took kinetic, which means energy in motion, and the elastic, which is no loss in the energy. We took it in the chemistry.
Okay, yeah, they are the same, they are science.
Right?
So the kinetic here in motion and the potential that is stored. Now let's talk about today what is the mechanical energy. Now, as I told you, next lessons, we are going to talk about the kinetic and potential. Today, we are going to talk about the mechanical and the examples of the mechanical energy. Now, what is the mechanical energy? The mechanical energy can be termed as the energy of movement. When it's meaning mechanical machines, okay? It is an energy of movement, as it is found in objects that are moving or have the potential to move. So that's mean, may I have an energy that is stored in myself, I use it to move, or while I'm moving, I have an energy. So the mechanical energy is an energy of movement. It could be an object that is already moving or objects that have an stored energy to move or potential energy to move. In physics, I mean, like it is the mechanical energy is a summation of kinetic plus potential. Mechanical is kinetic plus potential energy. Now, here also, since we have law of conservation of momentum, conservation of mass, we have a conservation of energy or mechanical energy. That's mean the mechanical energy of an object in a closed system remains constant if it is not under any force like friction or resistance except the gravitational force. So it's mean only that the mechanical energy in a closed system remains constant. There's no losses in the mechanical energy. It is still
About
constant.
close.
Sorry?
What do you mean about a closed system?
Closed system, it's mean like, how did you see the momentum?
Like you mean
Like something before, something after. It's closed.
oh, okay, thank you,
Okay,
teacher.
so see, tomorrow I will, not now, tomorrow I will bring a picture for you to tell you what is the closed system.
Okay, thank you,
Okay,
teacher.
but by the way, this lesson, later on we will talk about it. اللي هي law of conservation. But here, this is just an introduction here. Okay, when we are going to talk about law of conservation, I'll tell you what is the meaning of closed system.
Okay, teacher,
Okay?
thank you.
Yeah.
Okay.
Now, let's now come back here. So, since we have a law of conservation of momentum, we have a law of conservation of mechanical energy. Now, let us understand this concept by taking some examples here. Let's start with the first example, wrinkling ball. Sorry, 1 minute, please. Now look at this picture here, or this video. This is the first example of mechanical energy, which is wrinkling ball. Now, what is the wrinkling ball? A wrinkling ball is a large round structure that is used for the demolition of the buildings. Now, how we use it? Oh, what does it mean? Now, this is the definition of the wrecking ball. Now, when the ball is held at a height, I told you that any object, it stores energy. So this ball, when it is held at a height, when it is not moving, it holds a potential energy. So it holds a potential energy. It doesn't moving, but it isn't moving, but it's held at a height. So it has a potential energy. Now when it is full, so while it was here, look at here now. Okay. I'm sorry, I want to move it because I cannot now. So here, when it was held, when it's not moving, it has a potential energy. When it starts to fall, it's mean make motion. When it starts to move, it has now, or it's gained now, a kinetic energy. So at the beginning, it has a potential. After it moves, or after it starts falling, it's gain kinetic energy. So at the end here, so before falling, it has potential. After falling, it has potential and kinetic. Then, so we said also that potential plus a kinetic in physics is a mechanical energy. So by now, after the ball is falling, we have a mechanical energy, which is the potential that is stored, and the kinetic, which was from the movement. This mechanical energy cause a work. This work help the ball to make make a demolition on the buildings. Is it clear?
Yes.
Yes, teacher.
So here, before movement, it has only potential. After it starts moving or start to fall, it has an kinetic. So at the end, we have kinetic because it's moving, and we have a potential because it is in her storage. So it use this, both of these two energies, which are they? Potential and kinetic. They use both of them as a mechanical energy. That's, we know that the energy is converted to be as work, that we use this work to make her job. Let's have another example now. The hammer. Now look at this picture here. Here this sketched video. 2 minutes, please. Now look at the hammer here. Now as you see, the hammer is hit. The hammer hits the nail and drive it into the wall. This is the job of the hammer. It hit the nail and drive it, or going it to be inside the wall. Now, let's see now from where they bring this energy. The hammer, it does not contain, at rest, there's no kinetic energy. There's a hammer, it is a tool that you store it inside your room. You need it now to hit the nail, to hit the nail. So before it's take it, when it is at rest, there's no kinetic energy because it's not moving. But it has a potential energy since it was in storage. There's an energy that they store it in it. Now, after that, when you hit, or when you like swing or hit the hammer, you move it up and down. So you make it move. Since you make it move, you make it now. We have a kinetic energy. So at the end, we have kinetic and potential. Potential from the storage, kinetic since you are hitting it, since it's moving. So we have now a mechanical energy, because a mechanical plus potential is kinetic plus potential is a mechanical. So this mechanical energy now, it causes a work. This work can be used to drive or to hit the nail into the wall. Is it clear?
Teacher, can you repeat it one more time? The last part?
Okay. Now, the hammer, it is in your room now. It doesn't move. So that means it has a potential energy in it. It stores energy. Once it stores an energy, it is a potential energy. Now, you take it, you start to swing it into the wall, you hit it now on the nail. So once you hit it, you make it to move. Once it starts moving, it has a kinetic energy. This kinetic energy now, plus the first potential energy, make mechanical. This mechanical energy make a work to make a force to let a nail driving inside a wall, to let the hammer do its job.
Teacher, You mean about to make a work, not the work that we took that force through a distance, acting force. You mean like just a force, right?
Sorry?
When you say to make a work, you mean not the work that we took that is acting force through a distance. You mean just a force, right?
I mean, you said it is acting force through a distance. There's a force, and this is the distance. Sorry. And this is the distance between the hammer and the nail.
Yeah, they have the same direction, right?
Yes. Oh,
Yeah.
is
So
it clear now,
teacher,
honey?
the definition, just the definition of the kinetic energy again.
It's later on. It is the energy from movement. Tomorrow, inshallah, when I will give you to talk about kinetic and energy and potential in details. But here, just يعني introduced to you.
Yes, okay, teacher, thank you.
Okay, thank you.
Thank you, teacher.
You're welcome. Yeah, let's take now the third example, which is the windmill. Now, excuse me, but give now windmill. As you see here, or as you saw in the video here, this is the windmill. Start moving. Now, all of us know that some of the electrical energy that's we take it, or that's we take it or received in our home from the wind energy. How they, or from where we bring this wind energy? How can we get it? Now, the windmills are as an examples of the mechanical energy. Like when the air is start moving, so it's make a kinetic energy. This kinetic energy, it makes an work or ability to do the work on the plates of the fan. Now, so this work is applying a force, or sorry, the moving air make a force which is applying a work, which is make a mechanical energy to make the blades of the fan moving. So I'll repeat it here. Like you have an fan. When the fan is start moving, it makes an kinetic energy. This kinetic energy, it makes a work. This work done by the fan, this work now it's used to convert the mechanical energy to be as electrical energy that we make it from the, or we use it in our home, or in electricity. So here the moving fan, the fan when it starts moving because of the wind. The wind makes the fan start moving. When it starts moving, it makes a kinetic energy. This kinetic energy, or we can say it is a mechanical energy, it's convert, or it's make, or give a work, applied work on the fan to make to move. So it's later on is converted to be as electrical energy. This is a third example of the mechanical energy. Is it clear?
Yes, teacher.
You say when it make work.
Sorry, Rose?
Can you repeat it from what you said about the work here? Like just repeat it from when you said it will make work.
That's mean the kinetic energy, because it starts moving, or the mechanical, or we can say it is the mechanical energy. This mechanical energy give the air to ability to do work on the blades of the fan. When it starts moving now, it's make them rotate. So this rotation make later on converted to be as electricity, or an
like
electrical energy.
this moving fan will push the air in the same direction. So it will apply a force in it, right?
Moving fan. لا,
Yeah.
the wind. No, the wind is applying a force or applying or let the fan to start moving.
Oh,
Not
so
the
it's
fan let the wind to move. The wind let the fan to move.
okay. And direction it is moving. So
Yeah.
because of that, it's work and then it's mechanical.
Yes,
Thank you,
then
teacher.
this work they convert to be as electrical. You're welcome. Now the fourth example here, which is the bowling ball. Now look at this video here. This is the bowling ball that hits the target pins. I will repeat it. Now, the bowling ball consists of some amount of energy in the form of kinetic energy as soon as it starts rolling towards the target. Now, here I mean that the bowling ball, when it starts to move, it stores some kinetic or it makes some kinetic energy. This kinetic energy, they use it when it's reach the target. Where's the target? Which are the pins. So once it starts to move, it's gain kinetic energy. They used this kinetic energy to hit the pins. So that sometimes when you throw it with a little force, so that's its energy is will be very small, very little. So they cannot roll towards a big amount of pins. Maybe it hit one or two. But when you apply a large or greater force on it, so there's a greater kinetic energy will be, this greater kinetic energy will let her to cause a work that is applied, and it is make them, all of them or most of them will be hit. So the rolling ball here, it has a kinetic energy. When it starts moving, the ball, it is at rest. When it starts moving, it has a kinetic. Once it has a kinetic here, it hits, or it's going to the bells and hit them. So it has a mechanical energy that is use it to hit the balls. Is it clear?
Yes. Yeah, it is.
Yeah.
Now let's talk about the last example here, which is the cycling. Now here we are going to talk about a chemical potential energy. As we said, they are an example of an potential energy. Now, a person when is riding a bicycle, the person itself, it's gain or it has some potential energy. When it starts moving by work on the pedals, so it starts to make a motion. So they gain a kinetic energy. So both of the chemical potential energy and his kinetic energy make a mechanical energy that's led them to be as a work or it's been applying force to move the bicycle forward. Is it clear?
Yes.
Yeah.
Before it start moving, he has a chemical potential energy. After he start to play, or to can say work on the pedals or play on the of the bicycle, he's make now a kinetic energy. So at the end, he has kinetic plus potential. Both of them, they use this mechanical energy to make or to let the car, the bicycle, to start moving forward.
Teacher,
Yes,
teacher, now we said it's work because he is doing force in the bicycle, and these same forces are going to the same direction, right? Like
yes.
he's going upward, I mean like toward, and also the bicycle going towards, right?
You mean that the war here in the force and the distance are in the same direction.
Yeah, like
So
he's
that's why
doing
they make a dot. Yes,
the
make a
force
dot.
that he's doing the same.
Yes,
Thank you, teacher.
you're welcome. So that was our lesson. This is we talked just only today the definition of the mechanical energy.